Today's lesson is on properties from algebra, which we will work on for several days. Here's a quick summary of properties of equality. So we have addition property of equality, subtraction, multiplication, and division. All of these are properties from algebra. It's basically saying, for instance, addition, whenever we do to one side of the equation, we do the other. So if we add to one side, then we add to the other side. Same thing for subtraction. If we subtract from one side, we subtract from the other side of the equal sign, and same thing for multiplication and division. Now, if you're looking at the substitution property, you're going to say if A is equal to B, then I can either substitute A or B into any other equation or inequality. And looking at the reflexive property, I would say this one's a good one, like you're looking in a mirror. Whatever you, when you're looking in the mirror, you're getting your own reflection, so A is equal to A. Sometimes people confuse that with symmetric, which is why I like to make that analogy with the mirror. Symmetric means you're basically keeping things even. So if A is equal to B, then B is equal to A. And then last one, distributive. You've done this before a lot in algebra. If A times the quantity of B plus C, I'm going to distribute and take A times B plus A times C. Of all the properties from algebra, the transitive property is one that most students have not seen up to this point. So it's new to geometry. If A equals B and B equals C, then A equals C. So what I like to do in order to make this a little easier as we start building on it with our geometry topics, that I number what I have so far. So if I assign A number 1, since that's the first expression written, equals B on the other side, I'll make B 2. And B is, again, I'm going to renumber it as 2, and I haven't come across a C yet, so that's 3. Then A, which is 1, is equal to 3, which is C. So it basically goes 1 to 2, 2 to 3, and then 1 to 3, the first to the last. While you're doing this, if you can write them in that order and those numbers work out in that form, then you can say it's transitive. Otherwise, it's just substitution. So for example, if I just changed it slightly, if A is equal to B and C is equal to B, then A is equal to C. Although that is true, you're doing a form of substitution, 1 to 2, and then 3 to 2, and then I have 1 to 3. So it's this point right here, that little phrase C is equal to B, that puts it out of order slightly. So it is not transitive, it is then considered just substitution. As we move on to our properties of congruence, we've seen these in our properties of equality, but I just want to show you some examples there. So reflexive, I would say segment DE is congruent to segment DE, or I could say angle D is congruent to angle D. Again, it's reflexive. You're seeing the same thing back in the mirror, so they're exactly the same on either side. Symmetric is the same idea, but we're just going to switch the order. So if segment DE is congruent to segment FG, then segment FG is congruent to segment DE. Transitive shows up again in the same form. So if angle D is congruent to angle A, so I'll make that a 1 and angle E a 2. And angle E, again, I'll make that a 2, and angle F is a 3. Then angle D, again, which is 1, and angle F is 3. So again, it's in that form, 1 to 2, 2 to 3, 1 to 3. Now we're going to look at some examples. So the directions say to justify each statement. So I'm starting with number 1. It says if 3x is equal to negative 27, then x is equal to negative 9. So the question is, how did I get from here to here, or what did I do? The easiest thing, again, I like to say, well, I just need x by itself. That's what I'm concluding. So I go back to my original statement and I say 3x. Well, how could I make that an x? Well, I could divide both sides by 3. If I do that, I get x is equal to negative 9, which is exactly what I'm looking for. So how did I get there? Well, I divided both sides of the equation. So this is going to be division property of equality. Okay, because I'm dividing both sides. There's an equal sign, so I know I'm dealing with equality and not congruence. And looking at number 2, I have a few things going on here. I have if 3x plus y is equal to 20, so that's one statement, that's important, and y equals 2x. So that's my if, that's my hypothesis. Then I'm getting here, 3x plus 2x is equal to 20. Well, what did I do? I look at my first statement, and it says 3x plus y is equal to 20. Everything is the same from here to my final statement except for this y. So what did I do? Well, I looked at this statement right here and says y is equal to 2x, and I substituted. So if I start with my original statement, 3x, and instead of writing a y, I write a 2x, because I substituted, is equal to 20. That's exactly what I have as my final statement. So again, that is substitution property of equality, again, because I have an equal sign there. And looking at number 3, I have congruence. So I have angle A is congruent to angle C, and angle F is congruent to angle C, then angle A is congruent to angle F. Well, I have 3 separate statements there, so I'm going to number them to see if I get transitive. So A is 1, C is 2, because it's the second thing that showed up, F is 3. So then I have C is 2, and then I have A is 1, and F is 3. So I have 1 is to 2, and again, this part right here doesn't work. 1 is to 2, it should say 2 is to 3 if it's going to be transitive. So although this statement is not false, it is a true statement, it's just not transitive. So then I know it has to be substitution. So this is substitution property of congruence. Again, I'm really just checking to see if it's transitive. Transitive is a form of substitution. So let's look at number 4. If MA is equal to PY and PY is equal to 20, then MA is equal to 20. So again, I have 3 statements, so let's number them. So MA is 1, PY is 2. Again, I have another PY, so it becomes 2. I have 20, which is 3, because I haven't seen that yet. MA is 1, and 20 is 3. So I have 1, it goes to 2, 2 goes to 3, and then 1 goes to 3. So that is the form we're looking for when I'm looking for transitive. So this is transitive property of equality. In number 5, it just says the measure of angle A is equal to the measure of angle A. Because I have the same on both sides, it's like looking in a mirror, so it's reflexive. So it's reflexive property of congruence because I have a congruence symbol there. Let's look at number 6. It said if x is equal to 4b, then 4b is equal to x. I basically said the same statement, just reverse them. So they're in a different order. The one on the left goes to the right, and the one on the right goes to the left. So that is symmetric. So again, this is symmetric property of equality because of the fact that there's an equal sign. And let's take a look at our last few examples. It says if x equals 3, then x plus 5 is equal to 8. Well, we have to go from here to here. X equals 3, and then x plus 5 equals 8. So I'm going to write I'm going to write it again. Sometimes it helps to write things out so it's next to it. So again, here's my wall that I sometimes do in algebra, whatever. I do to one side, I do the other side. So how did I get from my x to x plus 5? What did I do? Well, I added 5. Okay, so if I add 5 here, and if I add 5 on the other side, then it looks like that's what I did, because I have x plus 5 is on my left, and 3 plus 5 gives me 8. So that's exactly what I did. So that's addition, property of equality. Addition, property of equality. Okay, and number 8, it says if 3y is equal to 4x, and 4x is equal to 2c, and 2c is equal to w, then 3y is equal to w. We have a lot of different statements going on here, so I am going to number them. So this 3y is 1, 4x is 2. Again, there appears my 4x, that makes it a 2. 2c is 3. Again, 2c appears again, which is 3. W I haven't seen yet, so that's 4. And then 3y is 1, and w is 4. So let's look at the pattern. 1 goes to 2. 1 goes to 2, and then 2 goes to 3, 3 goes to 4, and 1 goes to 4. So this actually is transitive. The order is right. Again, we've only been looking at 3 separate equality statements, but this one has 4 again, but the pattern's followed. It's just a little bit longer. So this is transitive property of equality.